research review. So this is one I was going to not do because it's a... Well, number one, I have a lot of work to do here. This is really cool. And then number two, it's like I've received this dose and I'm going to receive it more. And yeah, I don't know. Let's just keep hammering it in. The gift that keeps giving, exploiting Git integrations and cloud services by nopnop. So he gave a presentation version of this to the CTBB Critical Thinkers tier. It was really good. Yeah, so I think most of this content I've been through, but it made me realize some really crazy stuff that I didn't know. And there's like there's a certain trick here that like I just have a lot of work to do. 1. Introduction. Plenty of cloud services integrate Git. From my experience, the most common pattern is a service that lets you clone a remote repository, then view and edit the files through a web UI, and do Git operations like commit, diff, branch switching, and merging through the same interface. Under the hood, these translate to actual Git commands or library calls running on the server against your repository. There's already a big attack surface. This write-up looks at Git integration vulnerabilities from 2 angles. Git as an exploitation primitive, how Git's own features become exploit primitives. Git as attack surface, how the integration layer, CLI wrappers, URL handling, file operations, introduce vulnerabilities. This write-up doesn't cover specific CVEs in Git itself or other Git implementations, JGit, libgit2, GoGit, isomorphic Git, haha. Though those are also a risk when integrating Git into services. Instead, I walk through 4 vulnerabilities I found in Google Cloud Platform services, each exploiting a different aspect of Git integration. But first, the building blocks, what makes Git dangerous when it's part of a larger system. Yeah, so the bugs are cool. I've, seen them because they were part of the talk. I'm pretty sure it's the same ones. Very nice bugs. Very fun target. But we'll get into why. There's like a very specific behavior that like is not something I thought was a problem. You could even... Okay. Git as exploitation primitive. Git is complex software with a lot of features, and many of those features are powerful enough to serve as exploit primitives on their own. A config directive that runs a program, a symlink that points outside the repo, a hook that fires on checkout. When you're looking at a service that integrates Git, those features become vectors to escalate other bugs. Yeah, that's nice. That's a good point. 2.1 Git config for code execution. When a repository is cloned, the Git client creates .git directory inside. The directory holds Git's internal state, object database, refs, hooks, and configuration. The main configuration file is .git/config. I really want to like dig into Git source a bit more. There's just so many things here where it's like I should probably be doing some like novel research on the implementation to understand how certain things are resolved and if like there's support for alternative configuration files that are like how there's just so much stuff that gets stated and it's like how does that actually work, and it contains a number of options that can execute commands. I should pull my source. I have a checkout. I was looking at some stuff. Alright, so there we go. So we've got some directives for the Git config. So FS monitor, that's a fun one people love abusing. SSH command, yep. Git proxy, credential helper, filters, smudge and clean filters, yeah. Actually I need to fix my repo to actually get the Git attributes, whatever. Core pager, nice, yeah. Diff external, core editor, yeah. Does this? Yeah, you could get that already with FS monitor. If you can write to git config, you have RCE when the service uses the Git CLI. Assuming you have a way to trigger that. Even in append only, write is enough. Git's INI parser accepts multiple core sections. Last value wins. That's always good to know how that works. This applies to Git CLI only. Elaborate implementations usually don't execute these directives. You'd hope. Git hooks. Git hooks are scripts that fire on specific events. They live in .git/hooks or wherever core.hooks path points to some of the hooks, which I guess you can point that somewhere fun. Or if you're in a bare repo, it's just going to be hooks. I love being in a bare repo, by the way. It's such a great time. Alright. So yeah, you've got pre-commit, post-commit, post-checkout, post-merge, pre-push. Hope you're familiar with Git. If you're not, too bad. But you probably should be. Hooks can be used for code execution too. If you write a file into Git hooks named after one of those hooks, say post-checkout. Yeah, there's a ton. Aren't there more? Let me check my repo, because I know I have like a pretty gnarly repo I've been playing with lately. With yeah, there's some more hooks. That's just some of the hooks. Yeah, very very nice. You don't even need write access to .get hookspit. Specifically, if you can modify get config setting core.hooks path to a directory you already control, achieves the same thing. Get looks for hooks wherever that config tells it to. Yeah, there's been fun behaviors here. Bare repository tricks. This is where I get excited. Bare repository is a Git repo without a working tree. The internal files, head, config, objects, refs sit directly inside of a .git subdirectory. What makes a repo bare? Git decides something is a repository by looking for file markers. A minimal repo needs 4 things. I want to see the source citation of the Git client for this, because it's just like, just the way it decides what's going on is like very interesting. But I need to, yeah, honestly, like, if you want to follow up on this, someone break down the Git CLI code for this, and then break down the Git CLI code for, there was some other thing that I wanted to know how it was implemented. I mentioned it earlier, so the nice thing is it's video, so I'm speaking in append mode. I'm appending directly to the recording right now. I have no memory of anything I've said. It's not my problem. Okay, right, yeah, so yay, bare repos. So essentially, if you're running git CLI in a working directory and it sees these things, it's like, oh sick, bare repo. This is my repo. I'm gonna use this config. And it's like, oh wait, what? What do you mean you can stick a bare repo inside a subdirectory inside a real repo? I think that's what we're gonna be talking about. Buried bare repo, yeah. So buried bare repos, I didn't know you could do this, and this is kind of what's blown my mind. Yeah, if someone sees, yeah, so this is insane. Probably first learned about exploiting bare repos from this article. The idea: put a bare repo inside a regular repository subdirectory. If someone cds into the subdirectory and runs a git command, git discovers the bare repo, loads its configs, and executes whatever's there. So if you have some automation that, maybe the way it kicks off a workflow, clones some repo, cds into like dot my product, and then runs git log. I don't know if that one actually has a good way to trigger, but just runs git status. You can have a fs monitor trigger on that. That's just code execution. And it's like, wait, what do you mean? What do you mean I can have bare repos inside of my repo? Because yes, it's so cool. So that was the behavior I wasn't aware of, and that's what blew my mind. There's a catch though. A bare repo created with git in it bare has bare equals true in its config, and git refuses to run work tree operations like status and git status in bare repo. Don't worry, it's fine. To make this work, you need to tweak the config, set bare equals false, and add core.worktree pointing to a directory, even an empty one you create inside the repo. Yeah, and then git treats it as a normal repo with a work tree. Now git status works and core fs monitor files. Yes, yeah. This is so. I feel like so much white box review, you'll realize, oh, they just CD'd into some directory in some repo they just cloned that came from an arbitrary source, and now they're running a git command. That's just so, I didn't know that was so dangerous. But yeah, see, there we go. Look at that. This is exactly the situation I was describing. Okay. So you've got, this setup, and the nice thing though is that you can store git state like this on a normal git repo host because there's nothing illegal here. And so, yep, boom, pwned, rules. This also fires from any subdirectory within the bare repo, since git searches upwards and discovers the repo. Yeah, but it would be nice to be able to, from a black box point of view, it would be so cool to have a way that I almost want a wild card directory where it has that's not even from a file system perspective, that doesn't make any sense. But if they try to clone it and CD into any possible directory, it actually CDs into a bare repo. It's maybe you could have a word list of symlinks that you just ship. I don't know. That's not really. But I want shells, and it's this is so dangerous. And I think initially, looking at some of the references, there were a lot of things I think that had problems like this, which is I think people were partying pretty hard on this a few years ago. So honestly, this research, maybe I should have done the RR on this, because it's kind of I don't want to go all the way down the rabbit hole right now. This is like a good introduction, but yeah, this is what has me so pumped. Buried bare repo in a service context. The same pattern works against services that clone and process repositories. Yup. If you push a repo that contains a subdirectory with a malicious bare repo in it, and the service happens to run any Git commands within that subdirectory during a build step file scan deployment, Git finds the bare config repo and executes whatever core FS monitor points to. Correct. And that's like, honestly, I like understand now some of the figures that I think nopnop was talking about at some point, income-wise from bounties, and it's like, I don't know if I should say that, but this makes it all make sense now, because it must have been RCE in some baller-ass places. And so, yeah. I want to hack, and I feel like there's like, maybe I should come up with, I want to work out, I want better oracles, for understanding, especially when these black box systems touch these repos. Maybe I do just have like a word list of directories that if they happen to have something dumb that CDs into them or whatever, trip over a very nasty bare repo. With like, DNS callbacks using Git. So that way, because like, they're going to have the Git client and you can use that to trigger a DNS callback instead of like trying to do HTTP. I don't know. At some point when you're like trying to hit some of these like sandbox cloud service black boxes, it's like you want a really good payload. But confusing Git's repo detection. Deleting or corrupting .git head can make Git misidentify a repository, fail to recognize it, potentially falling through to a bare repo in a parent directory. Going the other way, creating a minimal .git structure, head, config objects, refs, in an arbitrary directory tricks Git into treating it as a repository with attacker controlled configuration. Yeah, so the this deletion trick was used by Talk in the, I don't even know, the research review I recorded in March, lost on disk, and then uploaded from an airport. I don't even remember. I think I uploaded it. I don't even know. Symlink handling, yeah, this is another reason why we party so hard, man. Git stores symlinks as blob objects containing the target path. If core.symlinks is true in git config, the default on Linux, Mac OS, Git creates a real file system symlink during checkout. If it's false, the default on Windows and in JGit, sad. Symlinks are just plain text files with a target path written in them. Symlink can point anywhere or repo with a symlink targeting, like relative traversals or /. We'll have Git create that symlink on checkout. If a service clones that repo and lets you read or write files through a web UI or API, you're hitting the real file system through the symlink. Yeah, that's the trick I'm much more familiar with. Fun behavior I've abused decently. Reading repo link password reads etc password. Writing to repo link cron d malicious writes a cron job. Found a couple of issues where services supported symlinks while cloning remote Git repositories. Exploitation is straightforward, and since the programs are private, I can't disclose the full details, but here's one of the program responses. I wouldn't even, it's too, what if they don't like that? Like, I don't know. I'd believe you. Like, it is like a kind of naive thing to go for quite a lot, because like, that's not going to work. And then when it does work, it's like, yes. Turning file primitives into Git exploitation. While hacking web apps with Git integration might end up with limited file system primitives. File read, a dirty write, or single file delete. One of these could be low impact, but combined with Git, they can be escalated to more severe vulnerabilities. Below is a short checklist of how different file system primitives can be exploited in the context of Git integration. Yeah, so this is nice. So let's say you have a file write, you can write some .git config that gets considered for some Git operations. You could write a hook. You could plant an entire like bare repo structure or a real or just like full after Git head deletion. You could Git uses the default SSH client for Git at write a proxy command directive, and the next get fetch or get push over SSH runs your code. Yeah, that's nice. Useful when .get is not writable. That's a cool trick. I think I saw that in the presentation and was like, nice. File append to get config, adding core sections of the execution directives. Yeah, that's nice that the last value wins. And then the file delete trick that we saw in the RioTalk write-up. File read to leak credentials. It's actually possible. Yeah, if they're like embedded in a remote URL maybe, or if the credential helper has a credential in the. That would be funny. Honestly, that's not even impossible. Symlinked paths. Of course, symlinks is enable reading files through symlinks, gives file system access beyond the repo. Oh, yeah. Git as attack surface case studies. These are vulnerabilities I found in Google Cloud Platform services. Each exploits different nuances of the Git integration, often changed with additional vulnerabilities. 3 of the issues described below are found in Looker during the Bug SWAT live hacking event. This just sounds like amazing. That must have been a great event. Everything I've heard from this, just wow. Looker is Google's business intelligence and data analytics platform. It has a built-in LookML IDE. I want to hack. It uses Git for version control. I have presentations I need to be working on right now, and I'm also waiting for a callback on a refresh token. It's complicated. I'm doing this instead. Allowing users to clone repositories, edit files, commit changes, manage branches through a web UI. For BugSwat, Google provides us both a cloud-hosted and self-hosted instance for testing, which gave us access to the source code. That just sounds like an amazing event. Like, wow. This is why I didn't want to do this, like research review another, because it's like, I've been aching for something like this. Like, I've been having dreams about featureful IDEs in high-paying programs. I don't know. Maybe I need to chill, but like, 3.1 argument injection file read via Git folder structure. Argument injection in Git happens when a value meant to be a positional argument, a file name, branch name, or repository gets interpreted as a command line option. Git, like most Unix tools, treats anything starting with dash as an option. Standard defense in depth is the dash separator, so Git check out some string. And branches are nice because branches can have all kinds of characters in them. If you're meeting the Git rules. Safe. Dash forces everything after to be positional. All. But argument injection goes beyond leading dashes. Different Git commands accept different options that can be abused. Some execute commands, upload pack exec, some write files, output some read files, path spec from file. Sonar source maintains a good reference of known argument injection vectors for Git. Man, I have a write-up on something like this from a while ago on my blog, but maybe could have tapped into this. Let's see, Git clone. What? Okay. One-line file read via argument injection in Looker. Looker, Google Cloud, uses the command line Git client for repository operations when SSH-based repos are configured. There's a Ruby wrapper method named CLI Git command that constructs shell commands by joining an array of arguments into a string. The escaping function strips most special characters but allows these guys. That's enough since dash and equals pass through file names starting with dash are treated as Git command line options. Nice. My initial goal was to inject dash file equals into Git commit, which reads the commit message from a specified file. Commit file equals etc password that would leak the full file contents in the commit message, but Looker runs git add or git rm on the file before the commit, and those commands don't have a dash file option, so the command would break before even reaching git commit. I defined an option that worked with git rm instead, which led me to path spec from file. When a file is removed through the Looker UI, the rm method runs, where s contains the user-controlled file name. No dash separator between the command and the file name. Here we go. I created a repository with the following folder structure: top-level folder name dash path spec from file equals a subfolder app inside it, And if, yeah, so that way it would like run git rm on that. So when this file is removed through the looker UI, git builds the path by joining the folder names with slash, and the executed command becomes, okay, there we go, yeah. So instead of removing the file, git rm reads /app.status server token as a path spec file. Note the leading slash. Git treats the value as an absolute path, so it reads /app/.status server token from the server's file system root. Looker's app directory, not a file inside my repo. Git tries to parse each line as a file path to remove, fails, and prints the content in the error message. Nice. Oh, nice. That's the first line of /app.status server token leaked through the error. In this case, the token gave access to Looker's internal endpoints like info token equals nice leak all the configuration options and secrets, and test process kill term token equals killing the server. Wow. There was one trick to the exploitation. Looker only tracks files with supported extensions .lkml and .json at C in the web UI. Oh, that sucks. So a file like .status server token wouldn't show up, but the file still exists in the cloned repo on disk. Okay. To make Looker pick it for removal, I moved the entire folder containing the file to another folder, which forced Looker to track all files inside it regardless of extension. This must have been such fun scope, man. Ah! Outcome accepted by Google Cloud VRP. Someone else submitted the same bug during the event's duplicate window, so the reward was split. Nice. So, yeah, nice. 3.2 remote code execution via folder path traversal on Looker. This one chained two issues: a path traversal that allowed creating a folder with an unsanitized name, and a command injection in Looker's Git implementation. This is the same CLI git command wrapper from section 3.1, but exploiting a different parameter: cd, working directory, and in command. Great! Is this even escaped? Second parameter command has escaping applied. The first parameter working directory does not. It's normally an internal path, not user input, so it was assumed safe. Looker's project generation endpoint accepts a folder name parameter for creating output directories. Nothing sanitizes it before hitting the folder creation function. Nice. Since setting folder name to something with shell meta characters creates a folder named under Looker's internal models user looker directory, the path traversal breaks out of the intended output directory, and the folder name itself is a shell command. Nice. Now, the second part, when a user is deleted from Looker, the before destroy method iterates through all folders and models user looker and passes each folder to prune worktree reference, which does something, which calls, here we go, something in a parent repo path. The folder name lands in working directory, the unescaped first parameter. The shell command becomes cd wherever, nice shell meta characters, and git worktree prune. Shell evaluates ID before anything else runs. The attacker needs developer permission to create the malicious folder. The command injection fires when any user is deleted from Looker, so the attacker creates the folder and waits for a routine user deletion to trigger the payload. There's routine user deletions. For the actual exploit, I used a base64 encoded reverse shell as the folder name. Yeah, so I don't know if you can get spaces through, but that's always a good trick. Yep, nice. Yeah. Man. Are there date headers? Yeah, this is a request. I want to see a response with a date header. Just curious when this was. I guess maybe one of these cookies. Here we go. Looker expires at. Okay, so this was 2025. Wow. Okay. IFS replaces spaces, which break the folder name up, in the base64 payload decodes to. Yep. Nice. Path traversal lands the folder in Looker's internal models user looker directory, confirming the payload is in place. When an admin deletes any user, the shell connects back. Wow. Nice. It was accepted, paid $30K, and show intel. Yeah, that's a great bug. I love it. I want to. RCE via path traversal and git config generation in Looker. Spent a good chunk of time during the event digging into Looker's Git implementation. I wanted a proper RCE, no preconditions, no waiting for an admin to delete a user. It just felt like it should be possible. After a lot of back and forth, I got it working. It ended up being the most complex bug I found during the event, and I submitted it on the last day just before the submission window closed. Finding the pieces. While hacking Looker, I noticed how it manages Git hooks. Every project gets a custom core hooks path valuing the generated .git config, which is //git hooks project name. I kept that in mind as a potential RCE vector. If I can control hooks path, point it at a directory with my own hooks script, that's RCE. But at that point, I had no way to control the value, since using the normal Looker flow for managing projects, it was not possible to put special symbols like ... in the project name. That's when I looked at LookML's remote dependency feature. What? Projects can import code from other Git repos by adding a remote dependency block to the manifest file. Cool. The dependency name, my dependency, becomes a folder name on disk, and ref branch tag or commit shop becomes a subfolder. Oh wow. I mean, I'm just like, can I get fun characters in? When you save the manifest, Looker creates the directory structure and generates the .git config file inside it. Neither the dependency name nor ref is sanitized. Both accept ... // sequences, 2 path traversals, and 1 feature. Wow, nice. And that's when hooks path clicked, the dependency name flows into the hooks path value in the generated config, and the ref controls where that config file lands on disk. I had control over the config value and where it gets written. Putting the chain together. Setting up ref to a path traversal pointing at another project's .git directory makes Looker write its generated config there, overwriting the existed one. The dependency name ends up in hooks path, so it can point at a directory with my hook script. The manifest remote dependency traversing back up to hit some other project's hooks, grabbing some repo with a ref that I guess matches a real ref. It's like a real branch here with that name, but then when that's used to create the file, is that where the actual repo lives? The ref traversal, it writes the config to Looker data model share model user target. The target project's Git directory. Okay. So there we go. The resulting config. When you create a project normally, Looker creates a folder named the same as the project's path. So in the example above, hooks path now points to a project I control called hooks, linked to a remote Git repo with a reverse shell payload and every hook script repo content looks like. Yeah, here we go. We've got way more stuff, and then I guess we needed a JSON because that was one of the things that I wanted to see. The Git hooks prefix. Looker always prepends ... Git hooks to the hooks path value. If that Git hooks directory doesn't exist on disk, the final path won't resolve by default. The folder did not exist on the Looker installation. I worked around it with another project to create their project with a manifest that abuses the same path traversal and ref to force creating that directory. Okay. The race condition. The full setup needed 4 Looker projects: hooks, Git repo with executable hook script, target, just a project whose .git config gets overwritten, create dir, force creates the Git hooks directory, and exploit the malicious manifest that overrides the target's config. Everything looked perfect for a nice RCE, but it didn't work. Turns out that Looker regenerates .git config before every Git command or every Git action performed via the web UI. Wow. So my overwritten config value gets replaced and breaks the exploitation chain. I had to win our race. Solution was simple. Burp intruder continuously resends the manifest save request while I triggered a Git operation on the target project, creating a new branch. The race was easy to win, and the hook fired after just a few attempts. Nice. Exploit summary. 1. Create a hooks project linked to a repo with malicious Git hook script. Create target project linked to normal repo. Create a create.dir project with a manifest that force creates the Git hooks directory via path traversal and ref. Create an exploit project with a manifest that overrides target Git config via path traversal, setting hooks path to the hooks project. Use burp intruder to repeatedly save the exploit manifest while creating a new branch on the target project to win the race condition. Okay. So one of these somehow has everything line up to get a config override on something that runs config stuff and then points at a hooks directory that has stuff copied from the evil repo, which I'm not. It's very cool. These are the last steps of the exploitation video I sent to Google VRP showing the race condition in reverse shell connecting back, and it was dupe, which I was live Matan. Okay. I was really surprised when I received a response from Google Cloud VRP that it was a duplicate. At first I thought that maybe someone reported it without full exploitation, but it turned out it was Liv Matan from Tenable reported the same thing one day earlier with almost the exact same exploitation method. Ouch. Yeah, that's unfortunate. Chaining primitives, npm symlink to JGet config to file system escape. The last bug in this article is in Google Dataform, a data pipeline tool built in BigQuery. It lets you write SQL workflows with JavaScript transformations, manage them in a Git repo, and schedule execution. It was in scope for another Google bug SWAT LHE in Vegas last year. While looking around the functionality, Dataform turned out to be an interesting target. It caught my attention specifically because of two features. Git and JavaScript. Man, they're giving them treats, man. They're feeding them treats at bug swats like that. That rules. If you can execute JavaScript and has Git integration, the JavaScript feature turned out to be properly sandboxed within the V8 engine. Meanwhile, Git was based on JGet and had the usual capabilities: clone a remote repository, review and edit files, commit changes, branches, etc. The unusual part was that it allowed installing npm packages as dependencies for JavaScript code. Can I access .git? Well, looking around the application, I noticed an API request that reads a file specified in the request from the Git repository. Path traversals did not work. That'd be too easy for a Google target. But when I tried to read .git, I got a specific error. That's interesting. I don't know why I never try to do that. I should try to read .git more often on these things. That told me, like, it's like, I would try to write there, sure, but like, what if I tried to read? And then with JGet, symlinks are, not gonna go nicely by default unless they're enabled. That told me Google probably implemented a blacklist to deny access to .git folder. Good news, it confirmed that .git exists in the file system within the repo, and blacklists tend to be bypassable. I think this is something I was like, just abuse a symlink, and it's like, okay, JGet defaults, no symlinks, I understand now. npm packages installation. The npm installation feature works like this. You create a package.json file within the repository, invoke the package installation function, and it installs the specified dependencies. While playing with package.json, the application threw an error that revealed npm is used on the back end. Wow. Using npm to install npm packages. Bold move. Bold move, Google. Knowing that, I started looking into npm's package.json documentation and trying things locally. I quickly noticed that npm supports referencing packages on the local file system. You can specify a dependency using file URI or a path starting with /nice. When npm installs a local dependency like this, it doesn't copy the files. Instead, it creates a symlink inside node modules pointing to the specified path. On my local machine, it was even possible to create symlinks pointing anywhere on the file system. Nice. That would create node modules traversal symlink pointing to. On Dataform, though, this doesn't work and threw an error, probably some restriction preventing access outside the repository folder, but Cassia / worked fine and created a symlink at node modules Cassia pointing to repository root. Since Dataform's file operations follow symlinks, node modules Cassia.git.config resolves to the actual .git config, bypassing the blacklist if it only checks whether the path begins with .git. Yeah. It worked, yeah. So can you write to it? Flipping core symlinks, the Dataform API allowed reading .git config through the symlink via the read file operation, but it also allowed writing to it via write file. Nice. Since JGet can't be used for RCE through .git config manipulation alone, no CoreFS monitor, no hooks, I went for enabling symlink support instead. I added symlinks equals true under core in .git config. On the next pull, JGet would create real system symlinks instead of plain text files. Nice. I'd prepared a Git repository with two branches. The main branch was clean. The symlink branch contained a symlink pointing to the root file system. After flipping core symlinks, I changed the remote branch to symlink and pulled. Nice. A nice surprise, JGet created a real symlink to symlink root pointed at /. The web UI now showed the entire file system of the code repository service through that symlink. Wow. Yeah, I want to hack something like this, man. Cross-tenant access. This is sadder, though, because it's black box, but it looks like you did a good job figuring it out. After quickly clicking around the file system and noting /code repositories folder, I realized the real impact. This was not just local to my project. The code repository services stored all their repositories on the same file system. Through the symlink, I could read and modify repositories belonging to other projects and other customers in the same region. Full cross-tenant access, both read and write. Nice. Perfect 10. So then you got MVA, Chippy. Defensive perspective. Git is complex on its own. Did we see what the bounty was? No. Hope it was good. Git is... Yeah, and that complexity opens paths for vulnerabilities, sometimes in areas developers don't even consider a threat at all. A few recommendations if you're implementing Git integrations in your service: input validation, sanitize values that flow into Git commands, repo names, branch paths, file paths, URLs, reject shell meta characters and leading dashes, always use dash to separate options from arguments. Yeah. Libraries over CLI, JGit, libgit2, and GoGit don't execute hooks or config directives, which kill most of the RCE vectors. If you must shell out, use argument arrays subprocessor on instead of string concatenations. Restrict .git access, block .git path at the web server, application, and file system levels. Don't forget. Indirect access, symlinks, path normalizations, URL encoding, resolved canonical paths before checking access. Yeah. Closing notes. Thanks to Google for an awesome VRP and opportunity to participate in Bug Swat Live hacking events. All bugs described in this article have been fixed. Finding 4 bugs and Git integrations across 2 events felt like a good validation that this attack surface is worth spending time on. Yeah. I strongly suggest looking into Git integrations if you come across one during your research or bug hunting. There's usually something there. Keep hacking. Wow, yeah, this is great. I like this. It's so cool that Google lets these kinds of things be disclosed, because, man, these bugs rule. So, how does this generally apply to bug bounty? Git is very complex, and it's apparently very dangerous, and so being able to, like, kind of focus on hotspots where there is a lot of stuff going on that touches dangerous syncs, like Git just touches so many dangerous syncs. It's like, oh wait, what do you mean if it's this, then it's this, then it's that? And just being able to have all the sources too, especially these cases where you can actually control pieces of the file system that get used, is very powerful. Where else can this be applied? That's my question to answer and not talk about, because because it's undisclosed bugs. That's my answer. Why did this work? Yeah, this is just a lot of good Git tricks. I liked the 4 that came together. I just want to go hack things right now, man. I'm gonna be real. Further research, yeah. So there's definitely interesting further research to do here. So some of the like black box hell testing, trying to build oracles for how they're interacting with your repo, maybe like, trying to have. You want to look at more at how the Git internal implementations work and see if there's actually what the exact requirements for things to be treated as bare repos are, and what the least primitives you need to cause like a corruption, like file delete, sure, but like, are there other limits needed? I don't know. And then trying to understand there's some other piece I thought would be a good follow-up research, whatever. I want to see the backing code for a lot of these things and make sure there's not any nuances we're missing that might lead to fun behaviors. Rating, I rate this bare equals false, work tree equals dot out of 10, because that's such a good trick, and I'm gonna go use that to get some critical vulnerabilities. Yeah, so I think really, really nice write-up, some really cool bugs. There's definitely ways to push some of this a bit further, I think, that I want to play with and kind of don't want to speculate on too far until I try to go and, pop some sick bugs. So I think this research is officially reviewed. Thanks for watching.